cyber mayhem. The match will begin in 3, 2, 1. Flags have been planted. Your team has owned a user flag. Your team has cloned a machine. Warning, your team is losing availability points. May your experience lead you to victory.
What's up, everyone? Welcome back. Welcome back to another Hack the Box talk. I'm genuinely hoping everyone's had a fantastic break, and it was a little bit better than we expected it was going to be earlier in this year. It's tough saying welcome back after the holidays are over. It's not a nice feeling, but onwards and upwards. We're hoping everyone had a fantastic holidays from Hack the Box and obviously from Spy Monkey and myself. And we're coming off the cusp of what was a crazy year. And what looks to be another crazy year. So let's make this a good year and let's be more driven towards learning. Before we go into the talk, we just want to say that if you guys have any questions, you can just drop them into the YouTube chat, and then Spy Monkey will bring them to my attention towards the end of the talk. Cool. So what is a password and what are they used for? Well, that's a really good question, right? So I think we're all quite familiar with the term of what a password is and what they do and everything like that, but they ultimately boil down to being sort of the club bouncer, the gatekeeper, or whatever you want to call it. But it's really your first line of defense in protecting your personal information. A password is essentially a string of characters that will give you admission to a service or an application. These are linked to a username to validate that the user logging in is who they claim to be. And when a username and password combination are submitted, the server will validate this combination to find a match with what is stored in the server database. I think it's safe to assume that we're all familiar with passwords. So let's move on to the topic of this evening, which is cracking passwords. Password cracking is the act of attempting to discover the plain text password, i.e. the human readable. Passwords often get stored on a server in hash format, making the password not readable or viewable by us. There are many reasons that people might look to crack a password. However, from the penetration testing perspective, the most common is to gain unauthorized access to a target. There are many types of password attacks that can be utilized to crack a password, and we'll be going through all of these in more detail throughout the presentation. Before we get into the attack types, though, let's briefly discuss password strength so that we can understand the purpose of having different attack methods. Password strength refers to how resilient a password is to brute forcing. There are many things to consider in order to make a strong password. The strength of a password is determined by the length, the complexity, and the unpredictability of the password. Length is the most crucial component of a strong password. The longer your password, the more difficult it will be for a brute force, and the less chance your password will be in your attacker's dictionary. When looking at the time taken to brute force, length is the biggest contributor to password cracking difficulty and might be what saves you from being exposed in a data breach. Complexity. Using complex characters and symbols will help extend the time taken to crack a password as well. This is because the amount of valid characters that can be used in a password increase, and the number of possible combinations therefore increase. For example, if we could only use lower characters in our password, which is obviously not advised, then every single space would then have an option of 26 characters that could be used, A to Z in alphabet, and 26 times 26 times 26 times 26, that's 456,976 combinations. Whereas if we allowed for capital letters as well, we ultimately double how many combinations in every single space, making this 7.3 million. So you can see just by adding capital letters as well, you increase dramatically the amount of combinations that could be used. We're kind of recommending complexity that you use symbols, capital letters, small case, numbers, those languages with the other different symbols and stuff like that, with the little dots on top, for example, and a shape if you can get one in. Obviously you can't, but if you could, it would help. Lastly is unpredictability. Using password as your password is really predictable. Using the name of the application, your birth date, your pets, etc. These are all really predictable. So when considering an unpredictable password, try and remove the password from personal attributes and try combining words or make a sentence. What I mean by this is don't make the password anything relating to you. By combining random words as well, you'll not only be contributing to the length, but also to the unpredictability. Sometimes taking phrases can also be a really good idea, such as to infinity and beyond. Cool. So now that we understand how a password can be made better, let's see how to crack the password. There are three main methods to cracking a password: brute force, dictionary, or a rainbow table. However, as technology and security has adapted, rainbow tables are not considered very effective now. Let's start with the most infamous one, the one that you've heard about in every hacking movie or every scene where hacking takes place, the brute force, right? A brute force attack relies on trial and error by checking all possible password combinations until the correct one is found. A brute force attack becomes less effective as passwords become longer, as said earlier. For example, using BetterBuy's password cracker estimator for the year 2020, that's a mouthful, the password with 9 A's shows an estimation of 3 days, 16 hours. Password with 10 A's shows 3 months and 5 days. However, adding another A increases the total time to 6 years and 10 months. This ultimately shows the value of a longer password. Every password is vulnerable to this attack. However, the length and complexity of your password can prolong how quickly your password is exposed and also deter attackers. What you're essentially attempting to do is make your password so difficult to crack that it takes years. Next is the dictionary attack. A dictionary attack is a form of brute force as well. However, instead of attempting every combination, you try the hash against a dictionary. A dictionary is essentially a list of common passwords that can be used to shorten the time of a straight brute force, where traditional brute forces try every possible combination systematically to break through authentication controls. Dictionary attacks use large, but limited, number of pre-selected words and phrases. These dictionaries are often comprised of past security breaches, common words, common phrases, usually very long words, and of course, common passwords. In terms of dictionary lists that we tend to use on Hack the Box or CTFs, the RockU word list is the preferred word list. Dictionary lists are also successful as humans are inherently bad at setting passwords, as we tend to resort to things we can remember. Using a password manager that creates a random string will most likely secure you from a dictionary attack. A rainbow table is a pre-computed dictionary of plain text passwords and their corresponding hash value. Rainbow tables have become a bit outdated with the power of computers these days, and they require large amounts of space to store the tables. Disk space used to be significantly cheaper than CPU time. However, this is no longer the case with what a few thousand rand can get you in terms of processing power. It was easier to pre-compute the rainbow tables than to do the hashes as you needed. Rainbow tables can also be prevented by using a salt, rendering the rainbow table hash is irrelevant, but more into this as we continue. Okay, so now we know how a few methods of cracking passwords. Let's briefly explain how password authentication works. Passwords have been around for centuries, from the Romans using watchwords to distinguish friend from foe, to Shakespeare starting Hamlet with "Long live the king" when Bernardo must prove he's a loyal soldier to the king of Denmark. Fast forward a few thousand years to the Massachusetts Institute of Technology, mid-1960s, where Fernando is introducing the idea of a computer password to secure shared resources. A password falls under the authentication method of something you know, meaning if somebody else gets to know it, then it'll be something they know and they can use it accordingly. In the interest of saving time, let's do a quick stepped walkthrough of how password authentication works. When you visit a site and create an account, you are required to create a username and password. The password is put through a hash process and stored in their database. When you log into that site again, you need to enter the created credentials. The entered password is put through the same hashing process again. The server then compares the stored hash with the newly received one, and if the hashes are an exact match, the user is granted access. So I've mentioned the word hash a few times this evening, and I'm sure most of you are already familiar with the word, but let me begin by describing the concept briefly to you so that we're all on the same page. I often find people getting confused between hashing and encryption. Although these terms sort of mean making something not readable, they're inherently different. Hashing is a one-way process, whereas encryption is not. When an encrypted message is received by the recipient, they'll be able to decrypt the message and read the information. hashing cannot be dehashed. In fact, encryption, decryption, and hashing are all words in the English dictionary. Dehashing is not. Hashing is a cryptographic function that converts data or a file of arbitrary length, which is considered practically impossible to invert. This guarantees that the hash of a plain text value can be generated. However, the process cannot be reversed. Most software and websites use this way to store passwords since the user knows the password, and the purpose is to avoid having the database with clear text credentials stored. So as we can see with this example, hashing a password is very specific to the exact given input. The first hash is for the word password, whereas the second hash is for the same word, just with a space at the end. And you can notice how obviously the hashes created are different. Hashing is also used for file integrity checking, as any change to a file, as we've just seen with the space, will create a different hash. This is used to guarantee that the file received has not been tampered with or altered. You might have seen the word checksum when you download a file from the internet, and this is to ensure that the download is complete and also exactly as expected from the download page. In this picture, we can see that the hashes don't match. The hash doesn't match the checksum on the left there, so therefore, somewhere between sending this or downloading the file has been altered. The most common hashing algorithms you'll probably come across are MD5, the SHA family, and bcrypt. In these examples below, they're all hashes of the word llama, just using different hashing methods. Identifying hash types is very, very tough, but for these three here are a few tips. MD5 is usually identified by 32 characters, hex characters, regardless of the original string. SHA-1 is usually 40 characters, and bcrypt includes this information at the beginning. The first part is the algorithm, the second part is the cost, and finally it's the salt and the hash. The other ways to identify hashes, there's a few pre-built into Kali. You have hash ID and hash identifier, where you supply the hash and it will try and determine what hashing method was used. There are also a few tools on Google, and we have covered Google Foo before and stuff. However, if you prefer an online method, you can use Google, and CyberChef is an awesome place to start if you're not sure. So I've mentioned salting a few times as well. Salt is a mineral composed of sodium chloride. No, I'm just kidding. We're not actually speaking about salt. That's such a poor joke. Yeah, but it had to be there. So what is salting when referring to cryptography? As we've discussed before, when a computer creates a hash of your password and checks it against the database, a problem can arise when two passwords are the same. If the hash is identical, it becomes a lot easier to crack the stolen database. So salting was introduced to avoid having the same hash for the same password, as well as to avoid the use of rainbow tables. Salting creates a unique hash for the same password by adding a random bit of data to the password before running it through the hashing algorithm. A salt will ultimately render rainbow tables useless, as pre-compiled hashes will no longer be valid as the salt has changed the hash output. So password managers often get a bad rep from those who don't really understand them. And I occasionally hear, I don't trust password managers as it acts as a single point of failure, which is true, but the benefits outweigh the potential exposure of all passwords. Let's quickly break them down by identifying some of their strongest benefits and covering some of their potential flaws. A password manager is ultimately a tool that stores all your passwords for applications, with a few added benefits such as generating strong passwords, quickly resetting passwords, autofilling passwords so you don't have to remember them, having the app or extension on any endpoint, as well as them sometimes offering breach detection. They can catch phishing sites if you didn't pick up the website was phishing by not autofilling, as it doesn't recognize the site. And also they allow you to remember old accounts that you want to delete, such as accounts that you no longer use and you want to remove the information that's stored on them. For those who want to check out manually if they've been exposed to a breach, Have I Been Pawned is probably the best place to check. It will show you, if you type in your email address, it will then show you've been involved in any data breaches and which of them you're involved in, as well as what information was exposed in that data breach. With the amount of login credentials we have to remember these days, people have a tendency to reuse passwords because remembering unique passwords per application or website is not reasonable. With this in mind, you can see why credential stuffing is such a successful attack vector. Credential stuffing is a cyber attack in which credentials obtained from a data breach on one service are used to attempt in are used to attempt to log in on another service. Only a few months ago, Spotify suffered a hack of 350,000 users through a credential stuffing attack. What a password manager can do is mitigate these attacks by ensuring you're never recycling your credentials. Having your password in multiple databases eventually increases the risk of having it exposed to an attacker and then granting them easy access to accounts that share that password. If you are worried about a single point of failure, be sure to enable 2FA, which you should be doing wherever you can. As regardless of if they find your master password, they'll need direct access to your mobile phone or however you choose to manage 2FA. And the same for obviously, password managers, you enable your 2FA and the attacker will still need to try and bypass 2FA. So now you know that cracking passwords can be time consuming. Let's give some information that will give you the best shot at cracking them. The best hardware to utilize for password cracking is actually your GPU, as they have hundreds, if not thousands of cores as opposed to your usual CPU. An example, your AMD EPYC server CPU has 64 cores, whereas the comparison, the new NVIDIA RTX 3090, that's for desktops, has 10,496 cores. Although a CPU core is much faster than a GPU core, password hashing is one of the functions that can be done in parallel very easily. This is what gives the GPU a massive edge in cracking passwords. Another tip for getting faster cracks is to customize your word list for your attack. Cool is a command line tool, which gives when given a URL, will spider a URL and return a list of words that can be used as a word list. Many websites will use passwords associated with the company, so pulling words from the website might give you a password for authentication or for password cracking. The latest example of this was the FireEye supply chain attack on SolarWinds. SolarWinds were using the password SolarWinds123 as the login credentials for their main FTP server, their patch downloads page. So Crunch is another word list generator that we should cover briefly. The use case for Crunch is more specific though. Crunch will produce all possible combinations and permutations for specific rules you set. Crunch is best when trying to make a password list that has random permutations on the rule you are setting, as it will generate all possible outputs. Crunch can get really complicated real fast, so therefore I won't really be covering this as this is a basic introduction. I just brought it up to make you aware of the tool if you have a specific case, and if you need to generate specific patterns, then the official man pages and Google, and you should be able to determine your goal or achieve a goal. So the two main tools that we're going to be using for actual password cracking is John the Ripper and Hashcat. John the Ripper is a free, popular password cracking tool. Kelly has John installed by default, and John the Ripper has an auto detect algorithm feature, so it will not require you to state the hash type, and this can be really useful. John the Ripper also offers some advanced tools that will convert password protected files, such as a zip file, an Excel, a PDF, SSH keys, and many more into hashes that can be cracked through John. I tend to forget the location of these tools, so I'll run locate to John to search through my VM for all the tools that will then convert a file into John the Ripper format. As you can see here, this is the output. So if I do locate to John, and you can kind of see the location and everything you want. I don't know, it says Bitcoin there, which was lots of money the other day, and a couple of other ones. Office to John is the one that will crack your Excels, your Word documents, and obviously Microsoft Office suites if they're password protected. So moving on from John the Ripper, you have Hashcat, which claims to be the fastest and the most advanced password recovery utility. It was built with the focus on being a GPU-based cracker. Hashcat is a lot more complicated than John, as you need to determine the hash type being used before and supply this hash mode into the tool. Once you have identified the hash, referring to Hashcat's hash examples will help you determine the hash mode to use when cracking. We'll go over some of these examples in the practical session soon. Installing Hashcat is really simple. It is recommended that you install Hashcat on your host machine and not your VM, because you want Hashcat to access the full power of your GPU. So if you head over to Hashcat's website, download the Windows Hashcat binary and extract the files into a folder of your location. And then it's a command line tool, so all you have to do is open like a PowerShell or a CMD and then just execute Hashcat with the flags necessary, such as the hash mode and the device you want to use, and your hash and your word list. And we'll also be covering this as well as we get into the practical sessions. So a few things that we can do with Hashcat are rule-based attacks, and something that in general we should be covering. A rule-based attack is getting into the more complicated side of attacks. So I won't be covering much on this topic, as this is an introduction still. I just want to make sure you are aware of the potential, and a quick Google will fill you in. So a rule-based attack allows you to manipulate a dictionary, to modify, cut, extend words, and has conditional operators to skip some, etc., stuff like that. That makes it the most flexible, accurate, and efficient attack. A good example of this would be adding an exclamation point to the end of your passwords, or changing the A's to @ symbols. With this sort of manipulation power, you can create some really strong password variations and drastically increase your chances of cracking. You'll also notice, though, as you start doing these dictionaries get really large. And the Rocky one I mentioned earlier is sort of 14 million or something like that, and that's not considered to be that big. So Hashcat will let you run these rules in memory, which is very, very nice. So lastly, I'll speak about masks. As I mentioned, word lists can get a bit long. It seemed like they owe you an efficiency option as well. And I know we've heard a lot about masks in 2020 with all this COVID talk, but these masks are really, really helpful. So stop flinching every time I say the word mask. Mask attacks are similar to brute force attacks, given they try all combinations from a set of characters. But with a brute force attack, all possible characters that exist are tried. Mask attacks are more specific, as the set of characters you try is reduced based on information you know. For example, if you know the last character in a password is a number, you can configure your mask to only try numbers at the end. Using traditional brute force, you'd still be forced to try all characters, A through Z, special characters, capital A's, lowercase. Whereas with the mask, you can state only try numbers. This could be helpful if they don't have if they do have a weird password policy that you've become familiar with. You happen to see the last bit of somebody typing their password and don't know what it started with. You find a torn piece of paper with half the password on it, or something to the sense. SpyMonkey wrote a fantastic article about cracking passwords using SAID numbers, as they're obviously not as random as you think. He used masks to slim down the potential birthdays because nobody has lived over 150 years old, as well as the non-random numbers in an ID number. This allowed him to actually crack, bank statements that send you your statement with an ID number in under 2 minutes. So this actually wraps up the theory for today. We have some prizes to give away and some practical examples to run through with you guys to test your skills. We aren't going to be expecting you to run big brute forces or complicated cracks, as we know hardware restrictions can be a factor for this topic. However, please come try at least crack a few with us so that you can get, familiar with the concepts and familiar with the tools that we'll be using. And lastly, while I have you all here, we have been asked by Hack the Box to try take a group photo today. So for those of you that don't mind turning on your webcam, showing us your ugly mug, would really appreciate it. And from here, we are going to be taking questions if there has been any. SpyMonkey?
No questions. We've just had some comments on your shirt. Everyone likes it.
Thank you. I thought it was nice and festive. I dressed up for the photo. So I'm happy to jump to Discord then, and I've got a couple of examples that we can go through then so that everyone can fire up machines. We can help people who need some installation help. John the Ripper been giving me trouble all day as well. SpyMonkey and I have been fighting with it, so I'm sure some of you might be as well. So we'll jump over to Discord then. We'll get going on some examples, and then once everyone's sort of feeling familiar, I'll send everyone the challenge, and obviously the first person to crack it will win the prize. Cool.
Okay, so everyone's moving over to Discord. Just join the main presentation voice chat on there.
Sweet.
Okay. Thank you. Cheers.
Cheers.